Hello. Today we are here with Ross Anderson. For me, again, a great honor and pleasure to have you on the CyberTalks. I think for me is a fundamental share of knowledge to be able to bring the greatest mindset of cybersecurity, and I'm one of your main followers, as you know. And Ross, I think we discussed last time a lot about the hyper-connected world, but today we're going to talk about assurance and sustainability. I quite like a quote from Dave Wellston that he states that security engineers are the litigation lawyers of tech. We only get paid when something is wrong, and we can always find something wrong. So how that applies with the new normal and also the hyper-connected world with the assurance and sustainability that we need?
Well, Rafael, in the old days, there were two types of secure thing that we knew how to make. First of all, you had things like phones, which are secure because you patch them every month. But the cost of that is that they run out of support after 3 years or perhaps 5 years because of the cost of patching. And the second type of secure object we had were things like cars and medical devices, which have software in them but are not connected to the internet, and you test them to death before you sell them, and then you never patch them. Now, the problem nowadays is that as we connect cars and medical devices and airplanes to the internet, that means that any vulnerabilities that are discovered in their software can be exploited potentially remotely and at scale. So we have to patch cars, medical devices, airplanes, electricity substations, and everything else, just like we patch phones and cars and laptops. Yet, what are the economics of patching a car for 20 years or patching an electricity substation for 40 years? We've never done that kind of thing before. There are very few pieces of software around that have been maintained continuously for 40 years. Perhaps LaTeX is the only one that I know of.
It's an interesting point that you're covering there, because now even more, for the last numbers that I look, IoTs, that I'm referring to cars, everything that is connected to the internet, and this scale is increasing as we speak. So the limitation on the software in terms of patching will become expensive. But how do we continue patching when we mixture, for example, the safety as well? Because it's not only security. I think last time that we spoke, you touched base on the kind of it's not only security now. Is if a car kills someone, we are talking about a little bit of safety. And then what is the implication with the security and the software on top? And the other thing is, as you mentioned, it's become very expensive. So how the industries are preparing themselves for the new kind of scenario, since the software patching is very expensive?
Well, there are some devices that we probably don't want to put software in, or at least not connected software. My classic example of this is a fridge. 2 or 3 years ago, everybody started selling fridges that had Wi-Fi connections. They were called smart fridges, and this was an excuse to charge you $200 or $300 more for your fridge. But nowadays, many of these are just frosty bricks because they relied on a cloud service to which they attached and which spoke to the fridge and also spoke to your phone. And once the fridge vendor can't be bothered to maintain the cloud service anymore, then you're dead. And instead of having a fridge that would last for 10 or 20 or 30 years, you bought a more expensive fridge that stopped working after 2 years. And this is why the European Union passed the Sales of Goods Directive last year, Directive 2019/771, which says that people who sell goods with digital components in Europe maintain these digital components for at least 2 years, or whatever is the reasonable expectation of the customer. And in the case of things like fridges and cars, that's going to be 10 years after the last device leaves the showroom. So all of a sudden, you can't sell a fridge and just patch it for 2 years. You have to patch it for 10 years. And if you can't justify that, then you must not give it any online connectivity at all. That's the law now.
Oh,
It's coming into force next year.
okay, no, thank you for bringing that over. There's a regulation there, but we are talking about Europe. But how maybe as we are hyper-connected, how the other vendors will be behaving, or in comparison in different countries, for example?
Well, the fact that we have got big regulatory ecosystems, one in Europe, one in America, and one in China, is just how the world works. And if you're in a country like Brazil, you have to ask yourself, which of these ecosystems do you end up attached to? Because if you end up being attached to the Chinese ecosystem, there's very little consumer protection at all for safety, right? Because the Chinese evolution in such directions is still primitive. The Communist Party has complete power. They don't care if people die. In America, regulation is slightly better, but it is still very pro-business. The safety regulation is best of all in Europe, for historical reasons. And that means that if you want domestic appliances or cars or industrial goods to be safe as well as secure, you might be better off buying goods that conform to European standards. Now, that doesn't necessarily mean goods from European vendors, because you might find European vendors selling goods in Brazil that are made to US standards. But that is something for Brazilian politicians to work out.
No, yeah, it's something new for Brazilians to be working, definitely. And I know that you are aware that Brazilians has passed the first kind of a copycat of a GDPR in Brazil. So it's the it's kind of our GDPR version in Brazil, and that is starting this year. So that is a kind of a first, I think, one of the first main victories for the cyber aspect in terms of keeping at least the data safe, that we know that is unrealistic for the scenario that we live at the current stage. But taking the point now that you are saying, but sometimes customers want features, once everything connected, they want maybe, we see so many IoTs that I don't see so many usability for being connected, for example, a kettle. But sometimes customers are looking for this kind of innovation, but they are not aware, particularly of the problems they can bring in his house, but also the consequences of a company to be able to patch everything. And not even though we live in a scenario of too many legacies already. So how we see the world from now, in probably in time, 5 years, let's not even go beyond 10 years, but up to 5 years, I think is going to be even worse.
Well, if you buy smart fridges that break after 2 years, rather than old-fashioned fridges that last for 20 years, then you've basically ripped yourself off. You end up creating environmental problems, consumers end up spending more money, you end up having disputes with shopkeepers, and ultimately, consumers tend to buy what advertisers push hard, right? So there is a role for government here. The government must say, if you're going to sell fridges, for example, in Europe, then you must maintain them for 10 years. Otherwise, it's illegal. And that means that in future, there won't be a lot of advertising of smart fridges in Europe because there is no call for smart fridges, right? It was just a stupid innovation that people did in order to sell more expensive products to stupid customers. Now, where things get more interesting is where putting smarts into products can add real value. And perhaps one of the more interesting cases there is the car, because you've had an awful lot of talk about self-driving cars, but it's not going anywhere because all you can practically do with a car is have an autopilot which will keep you in lane on the freeway. But once you get off the freeway and you start driving on country roads, you have to dodge ox carts and pedestrians and cows and all sorts of things, then forget it, it's not going to happen. So you have to have a realistic idea of what can be done with advanced driver automation systems, how much extra they will cost, and whether they will subtract from the lifetime of a car. Because you expect that a car will last in the UK 15 years. I don't know what it is in Brazil. Perhaps people keep it longer before they finally throw it away. Certainly if you go to Africa, you find that in countries like Kenya, cars are imported when they're already 10 years old. And then they're driven for another 15 years or so until they fall to pieces. And so if you're in Kenya, you need to be able to get patches for your software for 25 years after the car is sold.
In terms of the car, something that is just come to my mind when you said about what is autonomous car today is based on cameras, right? Because we don't have as well smart roads until now, right? I don't see that happening, and I think we are getting a piece of technology based on cameras and software, as has been described, and we are putting this into running to our old infrastructure, adding maybe some capabilities maybe in the future, near future, that's already happening. For example, the V2V that can talk to the other cars or even with the traffic lights. But is more devices connecting, is more software to be patched, is more security to be addressed. And this scenario is just growing. I think we're getting to a point that do we have enough professionals? Do we have to do something different? What do we have to do in order to help this, not to build something out of control that is start to happen already?
Well, the amount of automation that it is economical to use used to be a function of capital costs. Was it worthwhile to go and buy steam engines and then trains and then trucks and then cars? Nowadays, the hardware is cheaper and the software is more expensive, and most of the cost of the software is maintenance. And therefore, the sweet spot for the right amount of automation to use is going to depend on the costs of maintenance. Now, in a car, the costs of software maintenance are already limited by the fact that each car has got 50 to 100 different computers in it from maybe 20 or 30 different manufacturers. And doing the integration testing to get all these computers to work together properly is the big expensive problem, right? So patching cars is expensive, and it becomes more expensive over time, because if you have to patch a car for 10 years after sale, that means you have to patch it for 20 years. Right, because you're doing R&D on the car for 3 years, then for 7 years it is in the showroom being sold, and then 10 years after the last car is sold, that's 20 years in total. And if in Kenya they say that cars must be patched for 20 years, that means a total lifetime of 30 years, right? And then you have to ask yourself, how much automation is it economic to put into a car?
I think this bill is going to be quite expensive. In Brazil, I think people are running the car. We don't have the kind of a similar regulations in Europe that you have certain period of time to keep a car. Otherwise, it is not able to run anymore, or even MOTs and stuff like that.
So in the UK, for example, what are drivers' wages? In the UK, minimum wages for a driver might be something like $12 or $14 an hour. I suspect in Brazil it's less.
It's less, for sure. That's
maybe
for sure.
Half. But hey, so the economic amount of automation to put in a car is less. You don't need an autopilot system for driving on the freeway. Maybe it's useful to have an automatic emergency braking system, which will mitigate the risks of low-impact collisions in cities. I don't know. This is something you must work out.
Yeah, no, it's a very valid point. And changing a little bit for a different aspect now, what about medical devices? Because we have a bunch of medical devices. We are living a kind of a new landscape with devices that wasn't ready for be connecting to the internet, and now we are connecting. And also the data they flow. There are some devices that they particular the kind of a name or details of that patient is kind of a business for the criminals, right? So, and I think mixing legacy with a modern life and also the needs right now is a kind of is increasing, I think, the complexity for the environment for cybersecurity professionals to work, and also the business to sustain, since that becomes very expensive.
Yes, in medical devices, there are significant problems around safety usability. If you take, for example, infusion pumps, the pumps that they put in your arm to give you morphine if you have a car crash, these kill almost as many people as cars do, right? Because people make mistakes about what the drug dose is, and they might give you the whole afternoon's dose all in one dose, and so on and so forth. And so you have devices which are already rather dangerous, and you then connect these to Wi-Fi so that someone can go in over Wi-Fi and do an attack, or even just by mistake, by jamming the signal, can cause a bad thing to happen. Then what you find is that safety and security come together. And this may make the regulator insist on safer devices, because people may be prepared to take the risk of accidental death much more easily than they will take the risk of being deliberately killed by a hacker at the far side of the world. This is what they found in America. They had several hundred unsafe varieties of infusion pump, and 5 years ago, when somebody at the University of Michigan reported a Wi-Fi attack on one of these pumps, the FDA finally caused the pump to be recalled. Right? Yeah. So safety becomes more politically sensitive once it's mixed with security.
Since that you are mentioning that, I think it's very important to talk about a little bit what happened with the aviation, since the software issue, since it highlights everything that we are describing today, and this is highlight on your book, your new book that you're about to release. So it's typical, is exactly what we describe in the scenario that could happen when you combine software and safety together in the pet situation. So putting lives at risk sometimes due to the fact of what happened with the Boeing situation. That was a software issue.
Yep. Yes, the Boeing crashes are very interesting because they involved exactly the same combination of hardware failures, software design errors, and usability issues that we had seen back in 1985 with the Therac incidents. This is where therapeutic accelerators made by Atomic Energy of Canada injured half a dozen people and killed 3 or 4 people in America. So exactly the same problems that we teach every software engineering student, and we have been for years and years and years because of the Therac cases. Exactly the same problems come up in the Boeing case.
That's amazing, and I think for us to finish today, Ross, and thank you again for sharing your knowledge. I always appreciate. What do you see from the landscape for new students or maybe new people that wants to start maybe a career on the cybersecurity? How do you see as right now and in probably 5 to 10 years time or even more? I think there's a lot of plenty of opportunities there. But what, I mean, you being a professor of University of Cambridge, one of the main important universities in the UK. So how do you see, or what is your best advice for people that wants to start in this career path?
Well, the teaching that we give to our students has changed over the past 3 or 4 years. So I now teach safety engineering and security engineering together. And our first year course on software and security engineering, it can in fact be got on my website. I've made it available to the world. Thanks to the pandemic, I had to make all the lectures into video lectures. So I thought, well, why not just put them on YouTube? And of course, there's also my security engineering book. But there are 2 things here. The first is that it's important to understand the theoretical foundations of safety and security, which you get in a standard university degree and which you can get in textbooks. And second, it's necessary to get some practical wisdom about the world. And so my security engineering book gives lots of case studies of things that went wrong, mostly with security, but some also with safety. And then third, you have to go out into the world and get a real job for a real company that's dealing with real products and real people. You know, this is a practice, not just a theory, and unless you get your hands on real systems and understand what it's like trying to get systems designed and fielded, working with real people in real institutions, then you're going to miss a significant part of it.
No, it's a very great piece of advice, and I think it's a combination of factors, as you just say there. Ross, thank you very much for your time to be speaking with us and sharing your knowledge, and I really appreciate your time, and I hope next year, maybe depending how things are going, the invitation always being there, you know, maybe Brazil is knocking on your door again, but let's see how pandemic will be. Maybe we do online, or maybe a physical presence. Let's see how things will be moving forward in the near future. But thank you very much for your time.
Well, thank you. It would be great to be able to actually come to Brazil in person one day.
Oh, pleasure. Thank you, Ross.